Okay, this is the 2019 AMC 10B problem number 6, which was also the 12B problem 4, doing these problems by request. A positive integer n satisfies the equation n plus 1 factorial plus n plus 2 factorial equals 440 times n factorial. What is the sum of the digits of n? So we can't use the answers to our benefit. We're just going to proceed to try to solve. You should have some practice working with factorials. N plus 2 factorial is equal to n plus 2 times n plus 1 factorial. Because of that, we're going to factor in n plus 1 factorial out of the top, and it will leave us 1 plus n plus 2. This n plus 2 going here. Put this here if it helps. This is going to equal 440 times n factorial. Now, n plus 1 factorial is equal to n plus 1. You just subtract 1 and keep going. It's times n factorial, which is going to allow us to cancel with this and leave an n plus 1 behind. This becomes n plus 3, and it equals 440. Now, we could distribute this, move the 440 back over and refactor, but maybe we can just get it real quick. If you think about it, 44 and 10, we need numbers that are 2 apart. 44 and 10 is too big. The next logical thing to try is 20. And 22 times 20 is 440. 2 times 22, 44. Throw the 0 on the end. Then these are 2 apart. So this can be 22 and this can be 20, which would make n equal to 19. Plugging it in here, adding 3, it is 22. The sum of the digits 1 plus 9 equals 10. Okay, and now for the 2019 10B problem 7, which was also the 12B problem number 5. Each piece of candy in a store costs a whole number of cents. Pay attention to words like that. It usually means we're working with integers, like some properties of integers. Casper has exactly enough money to buy either 12 pieces of red candy, 14 pieces of green, 15 pieces of blue, or n pieces of purple. A piece of purple costs 20 cents. What is the smallest possible value of n? So you can get 12 red. This is the same cost as 14 green, the same cost of 15 blue, the same cost of n times p, but the price of p is 20 cents. So these are the price of blue, price of green, price of red. So we're going to have 20n. And it wants to know the smallest possible value of n. So you might just start plugging in numbers. You can see that to be a multiple of 15, it's going to have a 3, so maybe you put a 3, right, for n. But if you do that, you should quickly realize there's some answers over here, and they start at 18. So we probably shouldn't pick numbers for n that start below 18. Furthermore, if you analyze what's happening here, there's an inherent 7 inside of 14. We're going to need a 7 to be inside of n somewhere. There's only 2 answers that have a 7. This one's 21. Let's try it. You don't actually have to multiply and then try to divide the numbers in. You can just see if the factors match. 7 and 2, there's a 7 and 2 here. 5 and 3, there's a 5 and 20 and a 3 and 21. 12 has 4 and 3, there's a 4 in here and a 3 in there. We're pretty sure the answer is B. Okay, this is the 2019 10B problem number 8. The figure below shows a square and 4 equilateral triangles with each triangle having a side lying on the side of the square, such that each triangle has side length 2. So these are 2, 2, 2, and 2. And the third vertices of the triangles, that's the one in the middle, meet at the center of the square. The region inside the square but outside the triangles is shaded. What is the area of the shaded region? Okay, so this is shaded 2 technically, but I need to draw in there, so I didn't shade it. Okay, one way you can approach it, let's call this distance x and this distance x, because it's going to be equal on each side. Then the area of the entire square will be 2x plus 2 quantity squared. Now this is going to have to equal the area of each of these equilateral triangles. An equilateral triangle area is s squared root 3 over 4. we can plug 2 in here and it will cancel the 4, and there's 4 of them, so you get 4 root 3 plus. Now we need the shaded regions. Well, one thing you can do with the shaded regions, and it may occur to you, it may not, it might take a while for you to have this thought, but you can connect from here to the center. And now you have a triangle that looks like this, where this is the base of x, and the height is right here, which is the height of the equilateral triangle as well. And so since the equilateral triangle is cut in half, this is 1, and the height of it is root 3. So this is root 3 here and x here, and I can do 1/2 times x times root 3 to get the area of this triangle. Now, how many of these triangles are there? There's 2 for each shaded region. 2 here, x times root 3, 2 and 2 and 2. So there's 8 total. And you're just going to multiply by 8 to get 4x root 3. Next up, you can actually make this 2 times x plus 1 squared, like this. And so the square's outside, factoring a 2 out. Now I can take that 2 and square it and pull it out to have 4 times x plus 1 squared equals. Let's pull out over here 4 root 3. And you will have 1 plus x remaining. Now we know that x is not 0 or anything like that. We don't have to worry. We can just cancel one of these x plus 1's out, along with the 4. So the x plus 1 here squared just becomes x plus 1 equals root 3. And now we're going to subtract 1, x equals root 3 minus 1. Come back over to here. This was the area of the shaded region, which is what we're looking for. So we can just do 4 times root 3 times root 3 minus 1. 4 root 3 times root 3 is 12, and times this is minus 4 root 3, which is the answer. I didn't write them up here, but it's answer choice B. Okay, continuing on with the 2019 10B problem number 9. The function f is defined by f of x equals the greatest integer less than or equal to the absolute value of x minus the absolute value of the greatest integer less than or equal to x for all real numbers x, where the greatest integer less than or equal to r denotes what we just said. What is the range of f? Okay, range just means the output values. What are the output values we can get? Honestly, just start plugging in numbers. This looks weird. You don't know what's going to happen. Try a positive integer. Let's say you plug in 2. What's the absolute value of 2? It's 2. Rounded down to the nearest integer is still 2. So I get 2 minus 2 rounded down is 2. Absolute value is 2. We get 0. So one of them has to be 0. Unfortunately, all of the answers have 0 in it, so it's no benefit. Well, not much of a benefit at least. Okay, let's see what happens if we choose a positive decimal like 1.2. If I plug 1.2 in to here, I will still get 1.2, and then rounded down, it will be 1. And then if I plug in 1.2 to here, it will round down to 1, and absolute value is still 1. I still get 0. Let's try plugging in the negative integer. If I plug in negative 2 to here, it will become 2. Rounded down is 2. Same thing's going to happen over here. I'm going to get negative 2 rounded down is still negative 2 with the absolute value to 0. Last thing you should probably try then is a negative fraction. It doesn't really matter what, like 2/3 or 1/2. Negative 1/2, absolute value is positive 1/2. Rounded down is 0. Negative 1/2 rounded down, and this is the tricky part with greatest integer. If you think about what happens, 0 is here, negative 1 is here, you're located right here with negative 1/2. When I round down, it doesn't round down to 0. It rounds down to negative 1. Then I will have the absolute value of negative 1. The absolute value of negative 1 is positive 1, so I get 0 minus 1, which is negative 1. That gives answer choice A. Okay, and this is the 2019 10B problem 10, which was also the 12B problem number 6. In a given plane, points A and B are 10 units apart. So we'll just make a little line, put A and B, and label this 10. Okay, how many points C are there in the plane such that the perimeter of triangle ABC is 50 and the area is 100? Well, forget the perimeter for a second. Let's focus on the area of ABC being 100. We know we have a base of 10, so half times 10 times 20 will equal 100. So C is going to have to be located 20 units off of here. Just for starters, just make it something like isosceles right in the middle, right? And so if you make this 20 here, and you come down here, this will be 5 and 5. Okay, let's see what happens with this. Does this work? Can we make this, let's see what the perimeter is, basically. So 5 to 20 is a 1 to 4 ratio. So when you think of a similar triangle with 1 to 4, it'll be root 17. So I can scale back up to this, it'll be 5 root 17. Okay, now let's think about this. The perimeter of this right now is 10 for AB plus 10 root 17. Well, how big is that? Well, don't think about exactly what root 17 is. Think about something nearby like 10 root 16. Root 16 is 4, and 10 times 4 is 40, plus 10 is 50. This is just a little bit too big. It doesn't quite fit our criteria. What if we made a right triangle with 10 here and 20 here? This is a 1 to 2 ratio. Using the same trick here, 1 to 2 to root 5, this will be 10 root 5. So then 10 plus 20 is 30, and 10 root 5, how big is that? Well, it's a little bigger than 10 root 4, which would be 20. And 20 plus 20 plus 10 is 50, so this is again too big. What's going on here? Are there any? Well, let's think about it. If this is 20 and this is 10, I'm going to need the sum of the sides to be equal to 20. But there's no way any hypotenuse of any right triangle is ever going to be less than the altitude. So in fact, it means there's none. And the answer is A, which is 0.